Hi, this is Paul Solt from iPhone Dev TV, and we're going to continue working with numbers. So we were talking about integers, NSLog, floating point numbers, and some of the math functions that we can use in our applications. We're going to go ahead and create a new Xcode project. So let me get the mouse up. And let's jump through. So Xcode. This time we're going to go to an iOS application and then do single view application. Now we're going to do this because the numbers that we're using are very critical sort of to the architecture that we're developing on, and they are going to be different than what we'd get on an OS X application. So I just want to make sure that what you see in the simulator, I want to make sure that what you see in the simulator is actually what you'd see when you're writing your own iPhone applications. So we're going to hit next, and we're going to call this numbers. And then you fill in the appropriate information. Just go with iPhone. It really doesn't matter for this sample. We're going to hit next. I'm going to save it in my project folder on my desktop. I'll hit create. And for this example, we're going to go to viewcontroller.m. And I'm going to go ahead and delete some of this code and just get rid of the memory warning one. We're just going to insert some stuff right here in the viewDidLoad method after the super call. So we're not doing anything with user interface, but we are going to be playing with the numbers, and these are the same things that you'll use when you're creating an iPhone app. To start off, why don't we print out some of the most common things, and I'm going to start with char, int, and long. So I'm using a single quotation mark around the A. And then we can print that out. And I'm going to use the %C for character and then print out letter. Now, if I go ahead and run this with the play button up top, we'll see the iPhone pops up, and then what we care about is the output in the back. So letter is A. Now, I talked about letter being a number in the background. So let's print out the numerical representation using the integer %D. So I'm adding another part here, and then I'll just do comma letter. So we have letter twice, and one token is going to print it as a character. The other token is going to print it as an integer. So if we run it again, we see that A is equal to 97. And if I did the same thing for B and we ran it, we'd see B is 98. So A is 97, B is 98, C is 99, and so on. Now this is different for capital letters. So if I go ahead and rerun with a capital A, you'll see it's 65. All right, next up is int. So I can create an int number, and we'll do 21474834647. You don't have to do this. This should be int max, and this is going to be the maximum value that we can store. Then we can print this out using NSLog. And I'm just going to title it so that I know what I'm looking at. Use the %D and then type int number and parentheses and a semicolon. Go ahead and run this. The iPhone pops up and we see int number and then our number. All right, so that's working with integers and sort of that's a max value. So typically you won't use numbers that big in most applications. But when you do need to use a bigger number, you're going to use a long or a long. And let's just look at long. So I'm going to do long max. Now, this is a special constant, which I'm not sure if we can jump to. No, it's not going to tell me. But I can print this out and we can see how big this is. And we'll do LD, %LD. And if I go ahead and hit run, we'll see that a long integer is 2.1 billion. So it's a pretty big number. Now, the difference that we have now with the iPhone 5S is that it's got a 64-bit architecture, which means that the long numbers are actually bigger on the iPhone 5S than they are on the iPhone 5. And to show you how that's different, I'm going to switch what simulator is running. So up top, I'm going to switch over to the iPhone Retina 4-inch 64-bit. And when I do this and I hit run, it's going to start and we see a much bigger number. So this is where a long can actually be interpreted as a different number. And this can also lead to overflow issues if you're storing this data in the cloud and you have one app that uploads along on an iPhone 5 and one that uploads along on an iPhone 5S. And then you try to sync that and then you have an overflow issue on the device or something like that. But don't worry about that. We won't normally encounter that in our applications. As long as we stick to integers, you'll be okay. Let's look at what happens when we do overflow. So I'll create a new variable, and we'll call this overflow. And we'll set this to int max, which will be the maximum integer. And then if I print out what it is, and then I print out what it is plus 1, we'll see an overflow. All right, so I've typed it out twice, and the second time, we should see something different. So let's stop it and run it again. And now we see 2.1 billion, and then we see negative 2.1 billion. So this is an issue if you're running out of numbers to use in your application, and this can create some unexpected results that might make your application crash, or it might display something funny to the screen. And it's something that we have to think about, but in most cases, your application won't hit this limit. Next up, we're going to jump into some addition and multiplication. So let's do the 8 plus 4 times 2 so you can see what this does on your own computer. You can just type the expression right here and it will evaluate it. And then we go ahead and we stop and run. We see our expression and that's 16, just like we expected. Now if I do the same thing, I'll copy and paste it and put parentheses around 8 plus 4. And then I do that in our expression. So update it in 2 places so you can see the difference. And then we hit the run button. It's going to give us a different result. Down here, we can see 16 and 24. And so this is because there's a difference in the order of operations. All right, next up is integer division. So I'm going to do 5 divided by 2, and I forgot the equals %d. So make sure you have your token, otherwise you're going to have a warning. And then let's throw in the modulus operator. So that's going to be 5 modulus 2 is equal to %d. And then we'll do 5 modulus 2. So it's the percent sign, which is the modulus operator. And now I have an issue. So if we go ahead and run this, I don't know what will happen. We see some strange output. That's not what we were expecting, and we see invalid conversion specifier. So this is because the percent sign is a special character. You see how we used %d? In order to do a normal percent sign, we have to actually do %, and the first % will escape the second %, so it actually appears. So if I stop and run again, we'll see what we expected. 5 divided by 2 is equal to 2. It's integer division. We chop off the remainder, 2.5, and it just becomes 2. And then we know that if we take 2 times 2 and we subtract that from 5, we'll have 5 minus 4, which is 1. And that's what the modulus operator gives us. It gives us the remainder. All right, something else I want to throw in here are some shorthand operators. And I didn't talk about this in the mini lecture, but these allow us to write statements with less typing, and you'll see this a lot in other people's programs. So I just want to expose you to it so that you can sort of understand what's going on. We'll have an integer called count, and we'll set it to 5. Then what I want to do is I want to increment 5. So one way to do that is to say count is equal to count plus 1. Another way to do that is to say count plus plus. This is sort of where C++ gets its name. The plus plus is a special operator, much like addition or subtraction or division, but it's for computer programs. And what it does is it's shorthand notation for the line above. It's going to take count and add 1 to it. Well, let's go ahead and print out the value so we can see what's happening. So I'm going to do nslog count and then %d and then print out count. So we should see 6 after we do a count is equal to count plus 1. And then if we copy this line after the count plus plus, we should see 7. And let's see if I'm correct. All right, so we see 6 and then 7. So they're both adding to the value. Now we can do the same thing with minus minus. We could say count minus minus, and that would remove 1. So if we were to print out what we copied, we should now go back down to 6. So stop it and start it up again. And we see it's 6, 7, 6 down here. So you can play around with that, do it multiple times, see what happens. Next up is we have another way for adding more than a value without repeating our variable name. So much like the count plus plus only adds 1, or the count minus minus only subtracts 1, sometimes we want to add or subtract different quantities, and we can use another shorthand, which is count plus equals 100. And in this case, it's going to say, okay, count is equal to count plus 100. So it's going to add 100 to the value. And if we print this out, I'll just paste what I had there. We'll see that count is 106. So we added 100 to it. You can do the same thing with multiplication and division and subtraction. All right, so that's it for integers. Let's jump over to floating point values, also known as decimal numbers. I'm going to have float pi is equal to 3.14592653. Then I'm going to have float double pi is equal to the same number, so 3.14592653. And now we're going to print those two numbers out. Actually, I want a double, not float, so I'm going to fix that. And we're going to do nslog. I'm just going to call it pi1 and then print out a %f, which is for floating point numbers, and type in pi. And then I'll do the same thing, except call it pi2. And this would be double pi. I'm only using a shorthand notation here because I want the digits to match up so that we can see any differences. Let's stop and run that. And what we'll notice here is we're not seeing the original value in either of these. The output for the float is rounded, but we see an issue where the float value is 26 and our double value is 7. So why is it doing that? Well, because this digit right here is a 5, and if you round that up, this would become a 7. And so this value is being stored correctly on the double, but not on the float. So to really show you this issue, I'm going to print out more digits, and we can add a period and then 8 after the percent sign and period 8. Now when we stop and run this again, we'll see that on a float, the last two digits here are being rounded. So it's 2648 instead of 2653. And so if you round 4, that's going to go down. And so it's going to stay at 26, whereas you'd normally round 5. And so it would go up. And so that's why it was printing out 145927 for the double. And so this is the rounding issues that you can have with floating point values. And it can cause more issues the more you sort of multiply these values together. When you're using sort of less precise numbers and you need extreme accuracy, then you're going to want to use doubles. The downside of the doubles is it just takes up twice as much space in memory and on your hard drive. So if you're using a lot of doubles for scientific calculations, then you can run into issues where you run out of memory, and there's other sort of considerations that you have to think about. So that's a little bit more about the float and the double. Now let's talk about some math functions. So these are functions that we can call much like NSLog that allow us to do certain things. We can get a positive number, or we can do cosine and sine. So let's type up some examples here. Int positive number is equal to ABS, open parentheses, -13, close parentheses, semicolon. And we'll print that out. I'm just going to say absolute value of -13 is equal to %d, and then we'll paste in our positive number. And you could do this on one line, but I like to sometimes split up things just so it's easier to follow. And if we run this, we'll see that it flipped that sign bit, which is what we expected it to do. All right, next up is cosine, and let's look at two examples. I'm going to do this all in one line. So the cosine of x is equal to %f, and what our x value is going to be something that we pick. So I'll just go with 60, and then we can run this. Normally you would use a float to store the value of a cosine or a sine thing, or you could use double if you need more precision. So here we see a value, and that's not what we expect if we remember from math class, and that's because cosine deals with radians. So we have to convert from degrees to radians, and we can rewrite this expression so that it uses that conversion. So let's say cosine of 60, and then that's equal to %f, and cosine here of 60. Now this is where we do the conversion. It's going to be multiplied by pi, and so we can use the constant m_pi, and then we can divide by 180 degrees. And I'm going to put the .0 just to make sure that this is interpreted as a floating point value with a decimal place rather than an int, because if we did an int, we'd have the issue with integer division where it truncates, where it removes the decimal places. So let's finish this and run it. And if we come down here, we see the result that we would expect. All right, so that's working with numbers. I want you to play around with some of these variables, multiply them, divide them, work with sine, cosine, tangent. All right, so that's it. Just play around and let me know if you have any questions.